how do you write to files? Okay, this is one of those basic things that sooner or later you're going to have to do. It's fairly straightforward, but if you're not used to working with a modern language, it'll look different from things that you've seen up till now. Okay, so the first thing, if you want to talk to a file, you need to open it. The exception is there are some standard files that may or may not be open for you already. We'll talk about what those are. How do you write to a file? Closing a file. How do you read from a file? And the last thing, which is actually a little bit tricky, particularly with the Python 2 and Python 3 versions, how do you format text? Okay. When you open a file, you do it with the open statement, and you'll give it a file name, and you'll give it a mode of access. And that returns, I use FP for file pointer, but it's returning a file object, and we'll see what that means in a little bit. Okay? There are a lot of different modes you can open a file, but simplistically, you can open a file in read mode. That means you're not planning on changing it. The file must already exist because there's no point in trying to read a file that doesn't exist. Yes? For the file size. Can you restrict, if you're opening a file that already exists, can you okay, when you create a file, can you restrict its maximum size? Not as far as I know as part of the open. Okay, you can test the file and see how big it is, and then respond accordingly. But I don't think you can do something like that. And we're past the days of Fortran where you specified the length of the record and stuff like that. So if you want to open a file for writing, you can open it with the mode of W for write. You can also, and this is very useful, this was something I used in my error trapping example, open a file in mode append. What that does is it means I add to the end. If I try to open a file that doesn't exist with mode R, I'm going to get an exception because the file doesn't exist. I will not get an exception if I open a file that already exists for writing. It will happily write over it. But if you go to this this documentation here, you can find out how you can make sure that you're only opening a file that doesn't exist if you want to do that. By default, append will create a new file if the file doesn't exist, or it will add on to the end. Once you've created this file object, this file pointer, just like we saw, for example, with a list. When you create a list, you get routines that are associated with a list. When you create a file object, you get a bunch of routines. There's more than just this, but close, flush, name, read, read line, seek, tell, write lines. I'm not going to try to describe all of these, but I want to go through and show you the ones that matter the most. Yes, John? It's going to create a file. But if it already exists, it's going to open it and write over it. So there is no problem if the file exists with this mode. If you want to make sure that no file exists, there are multiple ways to do that. Okay. For people who are used to working with Unix, there's something called standard input and standard output. These are also defined in Windows, but they only really make sense, for that matter, in Unix as well, when you're working at what you could call a DOS window or a console window. What are these things? Well, this is where standard input is whatever you type at your window while you're running your routine. Standard output may or may not go somewhere depending on what you're doing, but if you're working from, again, a DOS box or a console window, the standard output is stuff that's going to be displayed. There's also something called standard error, which is where you are expected to send your error output. But let's think about this for a minute. We haven't talked about how you create GUIs, but what if you're running, you know, a program with a GUI interface, Microsoft Word, for example. Where are these things? Well, they don't really necessarily exist. So I mention these because there may be times when you want to send stuff, read from the terminal, or send to the terminal, but these channels exist, and you can just talk to them. You import sys, and you can then read from standard input, or write to standard output, or write to standard error. But you need to, and you don't need to open them; they're already there for you. But recognize that depending on what kind of programming you're doing, they may not really mean anything. So this is there for those of you who know what this is and want to use it. You're probably not going to, well, it depends on what you're doing. You may or may not do things which run from a terminal window. Okay, so to write to a file, you open it, then you write to it. The one thing that's a little different from many other languages, when you write to a file, it doesn't end the line. So if you wanted to write your file one character at a time, you could do that. When you want to end the line, you need to specifically tell it that you want to put a new line in. And I am reasonably certain, though I haven't played around with it to check, I should have, that this will translate to the carriage return code that's used on by your operating system. But I'm not 100% sure of that. There is a way to handle that, certainly. So here I've written a line of text, and I've specifically said end the line. This can be convenient. It can also be a real pain if you forget to do it, to get one long line. Okay. When you're done with using a file, you close it. Okay. Some of the documentation I've seen in Python would negate some of this statement here, but in practice, I have a routine here. It opens a file, it writes to it, and then it returns. This file is no longer defined. And we heard before that when something is no longer defined, then at some point Python will clean it up for us. So the trick is that Python may not do it immediately. So if you care, and you can actually even take this, and we can make this really simple in terms of number of lines. Here I have an open statement, and then I have a write statement to that file, since this open statement creates my file object, then I write to it, and then it goes away. And probably that's good enough if all you want to do is to open a file, stick something in it, and go away. But it's really better to stick in this fp.close. So even though this is possible as a substitution for here, I would write this code this way, and I would specifically put in, after my last write, fp.close, just like that, and make sure that my file is explicitly closed. Why would I do that? Well, I would do that because I don't want to take the chance that if this thing is called 50 times in a day and my program runs for 50 weeks, that it's not piling up many, many different open files. This forces Python, this inclusion here, forces Python to specifically get rid of everything that it's done and make the space available for reclaiming. Okay, so how about when you want to read from a file? So here I'm doing it from the command line. I am opening a file, and then I am reading a line from the file, and that's very simple with this for loop. How exactly this is working, I'm not going to talk about, but but if you just simply do a for loop over the file pointer, it will give you each line in the file one line at a time. So here I've printed it, and then I just simply, in this case, am printing out the line not including the last character. Why? Because the last character in each line is my carriage return. If I didn't do this, I would have a blank line in between each printout, which would be okay, but is not what I want. There is a routine, if you look in the documentation, called read lines, that does almost exactly the same thing that we just did here. I mention it so that if you see it, you'll know what you're seeing. The reason it's there is that they didn't come up with this very nice, clean syntax for working with file pointers until people had been working with language for a little while, and somebody said, "Gee, why don't we just make it work this way?" So there is this routine in there. You don't need to use it, and someday it may go away. I don't think it'll go away anytime soon, but it could. So it doesn't get much easier than this in terms of reading a file and working on it line by line. Question over there. FP is a variable. It's a variable that points to an object, but then again everything else that we've done is a variable that points to an object, but it's a particular type of object. It's not a list. It's not a it doesn't refer to data. It refers to a program. But we can make a variable that returns that references a routine. I mean, I could say FP equals open without any parentheses after it, and then FP becomes an alias for the word open, for the open routine. So it's nothing special. It's not any different from any other variable. But what's special about it is that it is the thing that it points to, the thing that we've referenced in that variable. Yes? How is closing it any different from deleting it? Closing it will force the closure of the file, and delete ought to do the same thing. But delete is depending on Python to recognize there are no other references to that. So there's sort of an extra level of indirection that might or may not happen. Close is specifically saying, I don't care how many other variables point. I mean, I could define, if I define FP this way, and then I say FP1 equals FP, and I forget about that, and then I delete FP, the file's still open because FP1 is still pointing to the file object, even though I've deleted it. But if I say fp.close, paren, or for fp1.close, then I have specifically said, pull that plug. FP1 is now pointing to a defunct file, and if you try to do anything with it, it will say the file is closed. Okay? The object still exists, but it exists in a closed fashion, and it's just better. And you'll get a much better diagnostic error message when you try to refer to it. Okay. So if all you're going to do with a file is read from it. Again, you don't even need to define a variable to point to that file object. This code here creates my file object. It doesn't happen to put it into a variable, and then it iterates over it. So that does exactly the same thing. Okay, works exactly what we did before, except once we've opened it, it keeps going back and getting a new line until we run out of lines. If you're going to do this kind of coding, I suggest you look into a new command in Python 2.6 called with that will force Python to clean up. But that's sort of fancy. If I were doing it, I would say FP, I would do it this way, and then once the loop finishes, I'd have a close. It's just so easy to follow. Well, this is a little bit more arcane, and the with statement, as my mind is very arcane. Okay. All right. There are plenty of other things that you can use to read from a file. There's a method or a function associated with file pointers that will return the entire file as a single string. Sometimes useful, but probably not. If you want to read that file in a sequence of bytes, you can use read followed by a number of bytes, and it will read exactly that number of bytes and return. Something you might need to use, but generally you don't want to. Readline returns back one line, just like what we did before. So if you wanted to read, and this I do use sometimes. Sometimes I will read a line from my file, and then I'll branch based on what I'm doing, and then I'll go to another section of code where I start looping over it and so on. So that's something you might want to use occasionally. Read lines, and notice there's an S on the end. We'll read the entire file in, again, one swell foop, but it will stick each line into a list of lines. So this is similar to what we saw before. Here I open the file, I read all the lines into a list, and now I iterate over the list. This is something that you will see in older code, but is actually not quite as clean as what we were doing before. Why? Because what we were doing before with the for where we pulled each line in one at a time, is that we only pulled in the lines as we needed them. Here we're taking the entire file, we're pulling it into memory, and we're then processing each line. So this is not the best way to use a file, to deal with files. If the file is short, it doesn't matter. If the file is very large, again, if it's a gigabyte file, then in order to do this, I've had to set aside a gigabyte of virtual memory, pull everything into that, and then process it. So I recommend, again, this is the cleanest way to work, unless there's some reason. I mean, there may be, if you're doing something that involves several passes over the file, where you want to scan it first to look for something, then you want to go back and start doing things based on what you saw in the first pass, then it might make sense to do something like this where you pull it all in and work with it. So it's going to depend a little bit on what you're doing, but for general purposes, you're better off using the newer syntax, which is, I'm sorry, this one right here. Okay. All right. One thing that people need to do all the time when you're doing scientific programming is pull in columns of numbers. Okay? And where either you've got numbers separated by, I've got a number, then I've got a bunch of spaces or tabs, then I've got another number or something like that, or maybe even text strings. And these are sometimes referred to, particularly in the Windows world, as comma-separated variable files, because that's what Excel calls them. There are a bunch of different ways of reading those files without having to resort to being your own parser and breaking up the things yourself. There's a built-in package called CSV, which I just reference here. We'll be talking next week about NumPy, which allows you to generate arrays of numbers. There is a routine that will take information from a text file and stick it directly into a NumPy array. So again, this is more for your notes, so when you get back to looking this up, you'll see a reference on where to go to work with files that are contain lots of ASCII or human readable numbers. So you don't need to rewrite all that stuff yourself. Let's see. Okay, last thing, and unfortunately not something that's real simple. You'll see something in Python that looks like this fairly frequently. You'll see a string, and then there's a bunch of different things preceded by a %sign, and then finally a %sign, and either a list or just a single value. And what happens when you do this? Well, in this case, I've given it a list. It'll take 1 and it'll stick it in %d. %d means format a decimal number. I'll do the same thing with the 2. When it comes to the 3, format a string. Well, the formatting of this string works exactly the same way as formatting formatting an int. So I get exactly the same result as if I'd put in a %d. The problem with this particular syntax is that at some point Python may get rid of it. As of Python 3, its use is depreciated, meaning it's discouraged. It still works in Python 3. But someday, maybe Python 4, version 4, something like that, someone will decide, I'm not going to keep fixing this code, we're just going to take it out. The same command in Python 4 is this. And I'm not going to teach exactly how this works. What this will do is this will substitute 1, which is argument 0, 2, which is argument 1, and 3, which is argument 2 in here. And the advantage of this is that unlike this one, where the sequence is dictated here, I could have done this where I put in argument 1, the second argument. The ordering is not fixed. This formatting is much more powerful. Problem is, if you're going to be programming on a beamline with Python 2.5, this isn't available to you yet. So I don't want to encourage people to use this in their code, and I don't want to encourage people to use this in their code if they're going to be working on at least on a BCDA, the BCDA version of Python. So what can you do? Well, here's some stuff that you can do in any version of Python, and it will take care of most of your needs. Okay? If you really want very fine control, you want to print out a specific number of decimal places or something like that, you've got no choice. You've got to use one of those 2 format statements that were in the previous example. But if all you want to do is do something simple where you want to create an ASCII string based on some input, but you can be a little flexible about how it is exactly displayed. This will work in any version. What we're doing is we're asking for the string version of each of these variables, and I'm concatenating it into a longer string. And this expression here will print exactly that. And this will work in any version of Python. So you might ask, what does this str do? Well, it turns out that there are two display items called str for string version and repr, which is the representation. And they will print out ASCII information about any Python object, or virtually any Python object. So if we look at the str version of 1.1 and the representation of 1.1, we see slightly different things. This one is intended as, the str version is intended as, this is what a human being wants to see as about my variable. While this one, the repr, is telling us as much as what Python has internally. So in many cases they will print exactly the same thing, but I looked around a little bit for this one to give you an example of something that would show differently. Okay, so take-home message: if you're printing something out for debugging, you want to know everything that Python knows as much as you, at least as much as you can, use this one. But if you're displaying something for a user to see it, use that. Okay, so you can do 90%, 99%, 50%, depends on what you're doing, with just code like this to take whatever you've got, convert it to a ASCII string, and then stick that into a larger ASCII string. And that way you'll always be able to, and that will allow you, I guess you could call that poor man's or poor woman's formatting. It's not necessarily, it's not as powerful, but it will give you code that will run everywhere. And I do have to say that I wish it were differently. I wish we weren't living at this transition between Python 2 and Python 3, but that's where we are. Okay, I think that's everything I have. Yeah, I've got some quick homework. So write a short Python script to create a file. As my example was, put your name, office location, phone extension. If you'd rather not do that because you consider that information confidential, you can write anything else you want to put in your file. And then have another short script that's going to read that file and then display it in a fashion like this, where you put in a line number to show you what you've got. Yes, John. Yeah. This one? Let's see. Tell me when I get to it. Oh, for what it's worth? The brackets would come right after that. Sorry. Yeah. Yeah, no, I'm sorry. This is a mistake. If I had been consistent, I would have put the brackets right there, and I would have left it for what it's worth. It's probably written at 4 in the morning. No, it wasn't written at 4 in the morning. Maybe on an airplane, though. Okay. All right. Yeah, please. You would be very foolish to redefine the definition of string, and this is getting way, way ahead of where I want to be, but you can define your own class, let's call it YonString, which will inherit all of the functions of string, of the str type, but change it a little bit so that when you, if you overrode str, you could change the way that that it gets displayed as a default string, you might not do that. You might let it use the default str, but its internal representation would print out, this is a Jan string type string with this value. This is, you know, I wanted to put this down, and if you defined, I think the way that it works is that if you define your own class and this underscore underscore str underscore underscore is not defined, it will default to this. And if this isn't defined, you'll get an error when you try to just display the object. But it depends on what it inherits from, because if the parent class has it, then you'll get it. So you don't have to, so unlike spec, you don't have to redefine it. You can just define on top of it. You define something that inherits from it. More questions? Okay. This is probably a good point to stop, even though it's a little early, rather than starting a new the next module. But if people really would like me to, I can continue at this point. How many people want to eat? Okay. All right. So I'll stop here. But before I do, any more questions? Yes. Mm-hmm. Sure. Yes. Mm-hmm. Right. Okay. You're running along code, and it hits some point where you hit an exception. Yeah. Well, yeah, it's sort of, you have to let me just start by saying, what's going on is that we've written a try block. We've put the code where we're anticipating we might get the error inside the try block. Yep. Right. Right. Let's see if I can give you, yeah. Mm-hmm. Right. Right. You only have one exception at a time. So well, actually the original exception went away in a sense as soon as you entered the clause that's dealing with that exception. You can retrieve information about the current exception, but I don't believe there's any kind of exception stack. But once you've done your raise, the next thing that handles upstream is going to only see what the exception you raised. There's only one exception being dealt with at a time. Yeah. So to reiterate that, if you're just running your code and you encounter and you encounter an exception, you're going to get whatever the default Python error handling is. But if you don't put it inside a try block, if you put it inside a try block, then and you encounter an exception, then one of several things can happen. If you have except followed by a matching exception class, it will do what's inside there. If you have except with either exception or no exception class, and you haven't matched it before, it will do what's in there. Even if you haven't done either of those things, it will still do what's inside the finally block. So, you know, I can't give you a simple rule that it's going to do what's in the except clause because it depends on whether it matches. But it will, but only if you have put the code inside a try block will it do anything based on the exception, other than the default behavior, which I believe actually is even overridable, but I wouldn't do that. And the important point is that you can nest try blocks. You won't necessarily do that from the standpoint that you're going to have one long routine and try, and then inside that tries, and then inside that more tries, because that gets awfully hard to read. But it's very common that you have, at the top level of your program, a try block, and then that calls multiple routines, and each of those routines has try blocks inside it. So the outer routine is there's a routine inside. You have a routine that happens to contain try blocks inside a try block. Yeah. Yep. If you want to trap an error, then you put everything inside a try block, and it's often and that's another good reason for using lots of small routines rather than writing 10,000 lines of code without ever calling another routine. You'll create code that's much easier to trap errors with by having lots of small routines. You'll create stuff that's much easier to test. You'll create code that's much easier for the poor slob who has to read what you've done, which might be you. So they're all good. Those are all good reasons, and frankly, it's not uncommon that I go back and I'll take code and I say, gee, this works, but I really want to test for this particular error now that I've seen that it happens. So I can just go to where I've called the routine and indent that little bit of code inside a try block. So let me see if I can just find. Yeah, I've got two. So this was the first example. Let's try trace demo 2. Okay, so here's the routine that I showed you, and this will work. And so I defined two routines. Let me edit that so you can get a feel for how it works. Okay, so here's my editor, and okay, and I don't need that one. Okay, so really the only, in a sense, normally executable code is this right here. So when it hits an exception, it will do this. And I'm just going to, so that we know that it happened, I'll add something here. So let's see. Okay, so we saw that we hit an error. If I do the same thing afterwards or before, the second time it's not inside a try block, so it doesn't get caught. And I get that trace back, and nothing happens from there on because I got kicked out of Python. Likewise, if I hit an error inside here, then my error is not going to get caught because I haven't put, because I'm no longer inside the try block. So you notice that even though there's more code for it to do after it hits this error, I have an uncaught exception when I get to this point here. I've never yet put a try block inside an accept, but I don't see any reason why you couldn't do that.